Hello, my name is Mariana and thank you so much for joining me today for this C++ crash course tutorial. I'm going to be your host for the day for this video. I will be going over about 26 topics today, and if for some reason something doesn't make any sense, I'll be sure to include my sources at the end and as well as link them down below so you can go ahead and take a look at them. So hopefully that will make more sense. So let's get into the video. I will be breaking down this entire video into 5 different sections. In the first section, we will be talking about 6 different topics, which are variables, assignment, namespace, streams, cin and cout, arithmetic operators, relational operators, and last but not least, logical operators. So getting right into it, a variable is a name which is associated with a value that can be changed. So for example, when I write int num equals to 23, I chose that because I'm 23, the variable name is num, which is associated with the value of 23. Now, even though we will not be covering this in this crash course, I feel it is important to let you know that int is a data type that represents that this variable can hold integer values. Now, for the sake of providing visuals for my visual learners out there, I have provided my own personal examples that will hopefully help you understand a little bit better. So we have int, our data type, and then num is equal to 23. Num is our variable name, and 23 is the value it holds. So I have provided the output, which is I am num, the variable, years old. And at the very bottom of the screen, you will see my output, which is I am 23 years old. Now we're going to move on to assignment operators. Assignment operators are used to assign value to a variable. So the left-hand side of the operand of the assignment operator is a variable, and the right-hand side of the operand of the assignment operator is a value. The value on the right-hand side must be of the same data type of the variable on the left-hand side, otherwise the compiler will raise an error. The first assignment operator that we will be looking into is the equal sign. This is the simplest assignment operator. So essentially this operator is used to assign the value on the right-hand side to the variable located on the left-hand side. So whenever we declare a variable, we will have our data type, our variable, our assignment operator, which in this case is the equal sign, and then we will have the value allocated for our variable. Now we move on to plus equals. This operator is a combination of the addition sign and equal sign operators, and this operator first adds the current value of the variable on the left-hand side to the value on the right-hand side. Then it assigns the result to the variable onto the left. Moving on to our next assignment operator, we have minus equals. This operator is a combination of the subtraction sign and the equal sign operators, and this operator first subtracts the current value of the variable on the left-hand side from the value on the right-hand side. Then it assigns the result to the variable on the left. So we have here integer a, which is equal to 5, integer b, which is equal to 2, and we have here b being subtracted from a, and from the output you can see that we have 3, so 2 subtracted from 5. Moving on to the next one, we have multiplication equals. This operator is a combination of an asterisk sign and an equal sign operators, basically implying multiplication. This operator first multiplies the current value of the variable on the left-hand side to the value on the right-hand side, and then assigns the result to the variable on the left-hand side. So we have integer a, which is 5, integer b, which is 2, and you multiply a times b. So we can see from my output that we got 10. Last but not least, we have division equals. This operator is a combination of a backslash and an equal sign operators. This operator first divides the current value of the variable on the left-hand side by the value on the right-hand side. Then it assigns the result to the variable onto the left-hand side. So here we have integer a, which is 6, integer b, which is 2, and you divide b from a, and you can see from my output that I got 3. Namespaces allow us to group name the entities that otherwise would have a global scope into narrower scopes, giving them namespace scope. It allows organizing the elements of programs into different logical scopes referred to by names. So a namespace is a declarative region that provides a scope to the identifiers, such as the names of types, function, and variables inside of it. Multiple namespace blocks with the same name are allowed. All declarations within those blocks are declared in the named scope. C++ comes with libraries which provide us with many ways for performing input and output. In C++, input and output is performed in the form of a sequence of bytes, or more commonly known as streams. So if the direction of flow of bytes from the device, for example a keyboard, to the main memory, then this process is called input. If the direction of flow of bytes is opposite, so from the main memory to the device, the display screen, then this is called output. In the standard output stream, also known as Cout, usually the standard output device is the display screen. The C++ Cout statement is the instance of the OStream class. It is used to produce output on the standard device, which is usually the display screen, and the data needed to be displayed on the screen is inserted into the standard output stream, also known as Cout, using the insertion operator of a double less than symbol. In the standard input stream, usually the input device in a computer is the keyboard. C++ cin statement is the instance of the class iStream and is used to read input from the standard input device, which is usually a keyboard. We have the extraction operator, which is represented by a double greater than symbol. And in this example here, the output is what does, 5 times 5 equal to, and my input was 25. Now we move on to arithmetic operators. These are used to perform arithmetic or mathematical operations on operands. So it is important to note that there are two types of arithmetic operators that we will be covering today. First, we have unary operators, and then we have binary operators. We will be looking into unary operators. These are operators that work with a single operand. So the arithmetic operators that fall into the unary arithmetic operators are the increment and decrement operators. The double addition operator is used to increment the value of an integer. So when placed before the variable name, which is called a pre-increment operator, its value is incremented instantly. And when it's placed after the variable name, also called a post-increment operator, its value is preserved temporarily until the execution of this statement, and it gets updated before the execution of the next statement. The double subtraction operator is used to decrement the value of an integer, and when placed before the variable name, it's called a pre-decrement operator. Its value is decremented instantly. And when it's placed after the variable name, it's called a post-decrement operator, and its value is preserved temporarily until the execution of this statement, and it gets updated before the execution of the next statement. Operators that work with two operands are binary operators. So the arithmetic operators that fall into the binary operators category would be addition, subtraction, multiplication, division, and modulus. So as I mentioned in the previous slide, binary operators include addition, subtraction, multiplication, division, and modulus. The first four mentioned are pretty self-explanatory. Modulus itself is like division, but instead of the output being the total, it's the remainder. So because 10 divided by 5 is 2, there's no decimals, there's no remainder, so therefore in this case modulus is 0. Relational operators are used for comparison of two values to understand the type of relationship a pair of numbers share. So for example, we'd have less than, greater than, equal to, and etc. So let's go ahead and take a look at them one by one. The equal to operator is represented as equals equals. The equal to operator checks whether two given operands are equal or not. If so, it returns true, otherwise it returns false. And the not equal to operator is represented as exclamation point equals. The not equal to operator checks whether the two given operands are equal or not. If not, it returns true, otherwise it returns false. It is the exact Boolean complement of the equals equals operator. So for example, if you have 5 exclamation point equal 5, it will return false. The greater than operator is represented by the greater than sign. It checks whether the first operand is greater than the second operand or not. The less than operator is represented by the less than sign, and it checks whether the first operand is less than the second operand. So in this example, we have x is equal to 7 and y is equal to 4. If x is greater than y, return true, otherwise return false. And if x is less than y, return true, otherwise return false. And we have here as our output true and then false. The greater than or equal to operator is represented by greater than and equal sign. This checks whether the first operand is greater than or equal to the second operand, and the less than or equal to operator is represented by less than or equal sign. This checks whether the first operand is less than or equal to the second operand. So here we have if x is greater than or equal to y, return true, otherwise false. And if x is less than or equal to y, return true or false. And our output is true and then false. Logical operators. They are used to combine two or more conditions or constraints, or to complement the evaluation of the original condition under consideration. There are three different types of logical operators, the first one being the logical AND operator, the second one being the logical OR operator, and last but not least, we have the third, which is logical NOT operator. The logical AND operator is represented by a double AND symbol. It returns true when both of the conditions under consideration are satisfied. So here we have if A is greater than B and C is equal to D, the output will be true. Otherwise, it'll be false. So while A is greater than B, C is not equal to D, therefore our output is false. Logical OR operators are represented by a double vertical line. This will return true even if one or both of the conditions under consideration are satisfied. So it's the same example. If A is greater than B or C is equal to D, our output will be true. Otherwise, it will be false. So A is greater than B and C is not equal to D. But because one of those conditions under consideration is satisfied, our output will be true. The logical OR operator is represented by a single exclamation point. This operator returns true if the condition in consideration is not satisfied. Otherwise, it returns false. So in this example, I have changed the value of variable A to 0. So for example, not A returns true if A is false. So in essence, when A is equal to 0. And here we can see that my output is true. So now we move on to section number 2. In section number 2, we're going to be covering the topics of conditional statements, loop statements, arrays, function, and function prototypes. Situations arise in programming where we need to make some decisions, and then based on these decisions, we will execute the next block of code. So for example, in C++, if X occurs, then execute Y, else execute Z. There can also be multiple conditions, like in C++, if X occurs, then execute P, else if condition Y occurs, execute Q, else execute R. This condition of C else if is one of the many ways of importing multiple conditions. The if statement is the most simple decision-making statement, also known as a conditional statement. It is used to decide whether a certain statement of block of statements will be executed or not. So in essence, if a certain condition is true, then a block of statement is executed. Otherwise, it's not. The if statement tells us that if a condition is true, it will execute a block of statements, and if the condition is false, it won't. But what if we wanted to do something else with the condition if it's false? So here comes the else statement. We can use the else statement with the if statement to execute a block of code when the condition is false. Loop statements in programming come into use when we need to repeatedly execute a block of statements. So for example, suppose we want to print out the word hello 10 different times. In loop, the statement needs to be written only once, and the loop will be executed 10 times as opposed to having to manually write the statement the 10 times. This way, it is more effective and you keep your lines of code shorter. In for loop, a loop variable is used to control the loop. So first we initialize this loop variable to some value, then we check whether this variable is less than or greater than the counter value. If the statement is true, then loop body is executed and the loop variable gets updated. The steps are repeated until the exit condition comes. While looking at for loops, in the previous slides, we have seen that the number of iterations is known beforehand. So in essence, the number of times that the loop body is needed to be executed is known to us. While loops, however, are used in situations where we do not need to know the exact number of iterations of loops beforehand. The loop execution is terminated on the basis of the test condition. An array is a series of elements of the same data type placed in adjacent memory locations that can be individually referenced by adding an index to a unique identifier. That means that, for example, 5 values of type integer can be declared as an array without having to declare 5 different variables, each with its own unique identifier. Instead, using an array with 5 integer values are stored in adjacent memory locations, and all 5 can be accessed using the same identifier with the proper index. An array index starts with the number 0, which means that the first array element is at index 0, second is at index 1, and so on and so forth. We use this information to display the array elements pictured on the left-hand side. Now, although that code worked perfectly fine, displaying all of the elements of an array like this is not necessarily recommended. So whenever you want to access a particular array element, then this is fine, but if you want to display all of the elements, then you should use a loop like the one pictured on the right-hand side to keep your code short. And our last topic for today, we'll be talking about functions. A function is a block of code which is used to perform a particular task. So for example, let's say that we want to write a large program, and in that program we want to do a particular task several numbers of times, like displaying a value from 1 to 10. And in order to do that, we have to write a few lines of code, and then we need to repeat these lines every time that we want to display the values. Another way of doing this is that we need to write these lines inside of a function and call that function every time we want to display these values. There are 2 types of functions in C++, built-in functions and user-defined functions. Built-in functions are also known as library functions. We don't need to declare and define these types of functions because they're already written inside the C++ libraries, such as IOStream, CMath, and etc. So we can directly call them whenever we need them. The function that we declare and write in our programs are user-defined functions. So in this example here, we have our function declaration, our main function, then we call the function, and then the function is defined after the main method. So in this case, we had addition, which is 1 plus 99, and our total is 100. And as you can see, that's what we have in our output. So moving on to function prototype now. So it's important to note that in C++, a function must be declared and defined before it is used or called anywhere in the program, whereas a function prototype is a declaration of the function that tells this program about the type of the value returned by the function and the number and the type of arguments. So a function prototype describes the function interface to the compiler by giving details such as the number and type of arguments and the type of the return values. The prototype declaration looks just like the function definition, except that it has no body, so in essence its code is missing. This would be a good time to note that there's a very clear difference between declaration and definition. A declaration introduces a function name to the program, whereas a definition is a declaration that also tells the program what the function is doing and how it's doing it. So now we move on to the third section of this video, which will include 5 different topics. The first one is header file, then we're going to move on to string, then we're going to move on to pointers, and then we're going to call by value, And last but not least, we're going to call by reference. Header files contain definitions of functions and variables, which are imported or used into any C++ program by using the preprocessor #include statement. So header files have an extension of .h, which contains a C++ function declaration and macro definition. So as we can see in this example here, I added the math.h header file. And basically what the math.h header file allows us to do is perform mathematical functions, such as being able to raise this integer x to any power, really. So I chose 2. And in this example, I asked the user to enter a number that they would like to square. I chose 4, and then at the bottom, you see that it's 16. So I raised it to the power of 2. Moving on to our next topic, which are strings. A string is a collection of characters or a group of characters. It's achieved in the C++ language by using array characters. So the string in the C++ language is a one-dimensional array of characters, which is terminated by a null character, so a /0. And in other words, the string is a collection of characters which is enclosed between 2 double quotes. In this example, I created a string that reads A, B, C, D, E, F, G. I wanted that string to be displayed in the output, and then I also wanted the output to include the length of the string. So as we can see here, the length of this string is 7, as there are 7 characters included within that string. Moving on to pointers. So as I had mentioned before, variables are explained as locations in the computer's memory which can be accessed by their identifiers, so their name. This way, the program does not need to care about the physical address of the data in the memory. It simply uses the identifier whenever it needs to refer to the variable. And the variable that stores the address of another variable is what in C++ is called a pointer. So our next topic covers call by value. So in call by value, the value being passed to the function is locally stored by the function parameter in stack memory location. So if you were to change the value of function parameter, it would be changed for the current function only. So it won't change the value of the variable inside of the caller method, such as main. Moving on to the next topic, which is call by reference. Here, the address of the value is passed in the function, so actual and formal arguments share the same address space. Hence, values changed inside of the function is reflected inside as well as the outside of the function. So, to understand the call by reference, you must have the basic knowledge of pointers. So let's just go ahead and move on to an example to try to understand this a little bit better. As we make our way onto section number 4 of this presentation or this video, we are going to be covering 5 different topics now. So we're going to look into structure, sorting, object, class, and access specifier. Structure is a user-defined data type which can store different types of data, such as items or elements, in a single variable. So then C++. Well, in C++ language, the array is a user-defined data type, but the array can only hold one type of data. So if we wanted to store different types of data, we would need to define separate variables for each type of data. So to resolve this problem, we use structure in C++ programming, and it can store different types of data in a single variable. So as I mentioned in the previous slide, a structure is somewhat like an array, except an array will only allow the user to input one type of data, whether it's integer, character, string. And in a structure, you have the ability to enter more than one data type. So you can enter characters, you can enter integers, you can enter string types. And in this example, I entered character and integer. Sorting is one of the most basic functions applied to data. It means arranging the data in a particular fashion, which can be increasing or decreasing or in chronological order. There is a built-in function in STL by the name of sort. This function internally uses intrasort, and in more detail, it is implemented using a hybrid of quicksort, heap sort, and insertion sort. Alright, so for this example, we are using the sorting function. So as you can see at the top, we created a function with an array called x, and we used a for loop to try to get the sorting done. Then if we can see, well, as we can see here, for array x, there's 10 different integers within that, and once it's sorted with the output, the display gives the correct order. C++ is a multi-paradigm programming language, meaning that it supports different programming styles. So one of the most popular ways to solve a programming problem is by creating objects, also known as object-oriented style programming. C++ definitely does support object-oriented style of programming, which allows you to divide complex problems into smaller sets by creating objects. So object is simply a collection of data and functions that act on those data. You can access the data members and member functions by using a dot operator. So for example, o2.function, this will call the function one function inside the test class for objects O2. Similarly, the data member can be accessed as o1.data2 is equal to 5.5. It is important to note that the private members can be accessed only from the inside of the class. So you can use the O2 function from any function or class in the example. However, the code O1 to data 5.5 always be inside the class test. So in this program, two data members, data1 and data2, and two member functions are defined under the test class. And this object O1 and O2 of the same class are declared. So before you can create an object in C++, you need to define a class. So a class is like a blueprint for the object. You can think of the class as a sketch or a prototype of a house. It contains all the details about the floors, doors, windows, etc. And based on these descriptions, we build the house. So technically the house is the object. And as many houses can be made from the same description, we can create many objects from this class. A class is defined in C++ using the keyword class followed by the name of the class. So the body of the class is defined inside the curly brackets and then terminated by a semicolon at the end. Right here we have a class named test, and this class has two data members, which is data1 and data2, and then two member functions, which are function1 and function2. So notice how we use the two keywords private and public. The private keyword makes data and functions private. Private data and functions can be accessed only from inside of the same class. So the public keyword makes data and functions public. Public data and functions can be accessed out of the class. So here data1 and data2 are private members, whereas function1 and function2 are public members. So if you try to access private data from outside of the class, the compiler throws an error. This is the feature in object-oriented programming known as data hiding. Moving on to the next topic, we have access specifier, and this is the last topic for this section, by the way. The keywords public, private, and protected are called access specifiers. So a class can have multiple public, protected, or private labeled sections. So it is important to note that by default, all members and functions of a class are private. So if no specific access is specified, then it goes straight to a private. So starting off, we're going to talk about access specifiers in C++. The public class members are accessible outside of the class and it is available for everyone. So if no specific class specifier or access specifier is mentioned within the class, then it will automatically go to private. But if you want to define a public, then you just use the keyword public with a colon. So moving on to private access specifier, the private class members are accessible within the class and it is not accessible outside of the class. So if someone tries to access outside of the class, it gives a compile time error, and by default, class variables and member functions are private, and this needs to be defined within the class function, and it is defined by private followed by a colon. So last but not least, we have the protected access specifier. So this is kind of similar to the private access specifier. It makes class member inaccessible outside of the class, but they can be accessed by any subclass of that class. So again, if you wanna define something as protected, it has to be defined within the class function, and it needs to be the word protected followed by a colon. We have finally reached the final section of this video presentation. So within this final section, or final and fifth section, we are going to be going over jump statements, which is something that I forgot to mention before, but it is important to know. We're going to talk about constructors, inheritance, overloading, file I/O, and last but not least, our final topic of the day is going to be binary search. Jump statements are used to alter the flow of control unconditionally. That is, jump statements transfer the program control within a function unconditionally. The jump statements defined in C++ are break, continue, go to, and return. In addition to these jump statements, a standard library function exit is used to jump out of an entire program. Now, in this crash course, we will only be covering break and continue. Break is a loop control statement that is used to terminate the loop. So as soon as the break statement is encountered from within a loop, the loop iteration stops there and the control returns to the loop immediately to the first statement after the loop. So basically, to break it down a little bit more, break statements are used in the situations where we are not sure about the actual number of iterations for the loop, or if we want to terminate the loop based on some condition. Continue is a loop control statement just like the break statement. However, the continue statement is opposite to that of the break statement. So instead of terminating the loop, it forces to execute the next iteration of the loop. And as the name suggests, the continue statement forces the loop to continue or execute the next iteration. So when the continue statement is executed in the loop, the code inside of the loop following the continue statement will be skipped and the next iteration of the loop will begin. A constructor is a member function of a class which initializes objects of a class. In C++, constructor is automatically called when object instance of class create. It is a special member function of the class, and a constructor is different from normal functions in the following ways. So a constructor has the same name as the class itself, constructors don't have a return type. A constructor is automatically called when an object is created, and if we do not specify constructor in C++, compiler generates a default constructor. We have three different types of constructors in C++. So we have default, parameterized, and copy. So the first one that we're going to be looking into is default constructors. Default constructors is a constructor which doesn't take any argument, and it has absolutely no parameters. The next type of constructor that I'm going to talk about is parameterized. Oh my god, that's hard to say. So it's possible to pass arguments to constructors. Typically, these arguments help initialize an object when it is created. So to create a parameterized constructor, simply add parameters to it the way you would to any other function. And when you define the constructor's body, use the parameters to initialize the object. Last but not least, I'm going to cover copy constructor. A copy constructor is a member function which initializes an object using another object of the same class. So whenever we define one or more non-default constructors with parameters for a class, a default constructor without parameters should also be explicitly defined, as the compiler will not provide a default constructor in this case. However, it is not necessary, but it's considered to be the best practice to always define a default constructor. The capability of a class to derive properties and characteristics of another class is called inheritance. Inheritance is one of the most important features of object-oriented programming. So why and when would we use inheritance? So consider a group of vehicles. You need to create classes for bus, car, and truck. The methods of fuel amount, capacity, and apply brakes will be the same for all three of the classes. So if we were to create these classes avoiding inheritance, then we would have to write down all these functions. The first type of inheritance that we have is single inheritance. In single inheritance, a class is allowed to inherit from only one class. So in essence, one subclass is inherited by one base class only. Next, we have multiple inheritance. Multiple inheritance is a feature of C++ where a class can inherit from more than one class. So in essence, one subclass is inherited from more than one base class. Now we have multi-level inheritance. Type of inheritance, a derived class is created from another derived class. At number 4, we have hierarchical inheritance. And in this type of inheritance, more than one subclass is inherited from a single base class. So in essence, more than one derived class is created from a single base class. Last but not least, we have a hybrid virtual inheritance. Hybrid inheritance is implemented by combining more than one type of inheritance. For example, combining hierarchical inheritance and multiple inheritance. And with that, we have come to the end of this beginner's crash course for C++. I hope that it was easy for everyone to follow and understand everything covered, every single topic covered in this crash course. If for some reason you had trouble understanding, I will make sure to link both of the main websites that I used for reference. Thank you. Bye.